Alternative theory of gravity. In this video I'm going to present an alternative theory of gravity. I'll start presentation with explanation of the nature of gravity. I'll compare interpretation of gravity given by new theory with Einstein's general theory of relativity. Then I'll talk about energy of mass, explain the meaning of the famous Einstein's formula, mc². In a third part the Newton's law of universal gravitation will be derived. Then we will talk about time and time dilation formula. The last part will be dedicated to implications of new theory, about repulsion of masses, critical density of mass and other. The nature of gravity. Theory of gravity can be called a theory only if it explains the nature of gravity. And looking into the history of science we should admit that there were not so many reasonable explanations of the phenomenon of attraction of masses. The first scientist who should be mentioned in relation to gravity is Galileo Galilei. He studied speed and velocity, gravity and free fall, the principle of relativity, inertia and projectile motion, all possible aspects of mass and gravity. He didn't develop a theory but provided a basis on which the theory could be created. Newton. Newton gave us a law of universal gravitation. Again, he didn't develop a complete theory of gravity but had very interesting ideas about ether as a cause of gravity which will be mentioned later in this presentation. Fatio and Lesage proposed similar kinetic theories of gravity with mechanical explanation of the Newton's gravitational force in terms of streams of tiny unseen particles, which impact all material objects from all directions. Their theory claimed that material objects are partially shielding each other from the unseen particles, and this shielding creates a pull between them. Although this theory was never widely accepted by scientists, it can be considered as one of the few physical explanations of the nature of gravity. General theory of relativity. Einstein's general theory of relativity can be considered as a most successful explanation of gravity, and it is acknowledged as an official theory of gravity. Einstein gave mathematical explanation of gravitational interactions between masses using four-dimensional space-time continuum which is curved by mass. General theory of relativity is the most interesting from the point of view of new theory of gravity because both theories have the same premises. Both theories are based on equivalence principle as it was formulated by Einstein in 1907, which sounds like following: we assume the complete physical equivalence of a gravitational field and a corresponding acceleration of the reference system. And I would like to highlight the part of this definition, complete physical equivalence, because as we'll see later this phrase will be very important in a logical argumentation of new theory. In the other words, equivalence principle can be described as: an observer in a room without windows cannot distinguish between being on the surface of the Earth and being in a spaceship in deep space accelerating at 1g. It is obvious that in the case of accelerating spaceship all objects in its cabin independent of their masses will move with the same acceleration, and every object will experience inertial force proportional to its mass and directed opposite to the direction of motion. But we also know that inertial forces are not real. There is no force which attracts passenger to the front of the bus when the bus stops. And there is no force of attraction at the back of the bus when the bus accelerates. In both cases the forces are fictitious. Fictitious nature of the force of gravity can be revealed in the case of free fall. All objects in free-falling cabin are weightless, which indicates that they are moving in an inertial system. So, accelerating motion by the force of gravity is an inertial motion. Then gravity is not a real force. Einstein called this idea as his happiest thought. Gravity is not a force. And I completely agree with this statement. Gravity as we experience it on the Earth is not a real force. Up to this point new theory completely agrees with Einstein's general theory of relativity. The difference starts in interpretation of this basic knowledge. Einstein said that gravitational acceleration is an inertial motion in four-dimensional space-time continuum curved by the bigger mass. Astronauts flying around the Earth on the orbit are sure that they are moving in a straight line at a constant speed. In a curved space-time surface of the Earth is non-inertial frame of reference and moving upward with acceleration 1g. Curved space-time or four-dimensional space-time continuum explains everything. But do we really understand what the space-time is? Does it look like a space stuffed with clocks? Or like rubber trampoline curved with a massive ball? The four-dimensional space-time continuum is something unimaginable. In our three-dimensional space we cannot imagine something four-dimensional. It exists only on a paper in the math formulas. And now we can ask a question: is there complete physical equivalence between gravity and inertia in Einstein's model? Several times when I've tried to explain to somebody main principles of general relativity starting with equivalence principle, I've been asked, does acceleration produce curved space-time the same way as gravity? Good question. Einstein said that inertia is the gravitational coupling between matter and space-time. But does this mean that there is complete physical equivalence between inertia and gravity? For me there are more questions than answers. Do we have answer on a question what is mass, besides that it's equivalent to energy by mc square? Then what is energy? We are talking about space-time, but what is space? And what is time? 100 years passed since general relativity was published, but the most popular topic on a theoretical physics forums is, what is time? We agree with the statement that gravity is not a real force, but do we actually know what the real force is? Alternative theory of gravity has to answer to all these questions. Let's return to equivalence principle and especially to the part of it about complete physical equivalence. What it means to be complete physical equivalent. On this picture we can see a woman which hair is flying on the wind. What is the cause of this situation? Probably she is driving a sports car. Or maybe she is standing near to the big fan which is blowing air into her face. In a first case girl is moving through the still air, and in a second case she is standing still but the air is moving. Two cases are different but result is the same, hair is moving by the molecules of air. Both cases are completely equivalent. In a case of gravity or non-inertial systems we have to consider not uniform but accelerated motion. And we know that acceleration can be measured relative to an inertial object, like a falling apple, or we can use an accelerometer. In both cases we will measure proper acceleration. Proper acceleration is not the same as coordinate acceleration. For example, an accelerometer at rest on the surface of the Earth will measure acceleration due to Earth's gravity. By contrast, accelerometer in free fall will measure zero. Placed into a spaceship with a switched-off engine in a deep space, accelerometer will show nothing because the system is inertial. But at the very moment when the engine is switched on, accelerometer will show acceleration of the spaceship. Relative to what accelerometer measures acceleration? And there is a Mach's principle which says that local physical laws are determined by the large-scale structure of the universe. It suggests that acceleration is relative to the fixed background, which Einstein describes as the fixed stars. But most physicists believe Mach's principle was never developed into a quantitative physical theory that would explain a mechanism by which the stars can have such an effect. So, if it is not fixed stars, then what is the reference frame? Let's think about it. Our spaceship moves in an empty space, then maybe we can accept that this empty space serves as an inertial reference frame. Then proper acceleration is acceleration relative to surrounding space, and we can consider space as a universal inertial frame of reference. If we accept that on non-inertial spaceship accelerometer measures acceleration relative to surrounding space, then what accelerometer measures on Earth? Can we expect that on the Earth it also measures acceleration relative to space? If yes, then space is accelerating relative to the surface of our planet. And it is not the Earth is moving upward as Einstein said, but it is space which is moving downwards. And now we can apply a test of complete equivalence between inertial force and gravity. We can see that acceleration of mass in space is completely equivalent to acceleration of space relative to mass, the same way as we had in an example with the woman driving car or standing near to the fan. This approach allows explaining why every object in a free fall experiences weightlessness the same way as astronauts in an inertial spaceship. It happens because free-falling object is moving together with space or with the constant speed relative to it. There is no acceleration relative to space in free fall. And now we come to the main question of the theory. How can mass create an accelerating flow of space towards itself? And there is only one answer to this question: matter absorbs space. And to balance matter, antimatter has to emit space. So, the first question to new theory: what is the mass? Mass is the property of matter to absorb space. Here comes the second question: what is space? Albert Einstein wrote in 1920, "We may say that according to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. But the idea of motion may not be applied to it." Is this true? Let's remember famous Michelson and Morley experiment, where they tried to measure speed of the ether wind, which has to exist if Earth is moving through the stationary ether. Experiment failed because no ether wind could be registered. And the main result of this experiment was, stationary ether doesn't exist. Or, by the other words, space or ether is not stationary. Now is a good time to remember Newton's ideas about gravity and ether. Newton describes ether as a medium that flows continually downward toward the Earth's surface and is partially absorbed and partially diffused. This circulation of ether is what he associated the force of gravity with to help explain the action of gravity in a non-mechanical fashion. Doesn't it look familiar? It's almost exact description of new theory of gravity. And now returning to the Michelson-Morley experiment, we can ask, could they register fluid ether which is moving perpendicular to the surface of the Earth? And the answer is no. Result of their experiment can be easily explained from the point of view of new theory. Then the answer to the question what is the space or ether, will be, first, space is a discrete substance. It is hard to imagine that mass is absorbing something continuous. And the second, space consists of the massless cells, or particles of space, which can be moved and absorbed by mass. I prefer to use the name of the space cells instead of particles, because notion of particles implies that they can move by themselves, which cannot be applied to space cells. Space can be rather compared to the soap foam, where every space bubble is always surrounded by the other bubbles. Alternative theory of gravity, part 2, where we'll talk about total energy of mass. This part is dedicated to probably the most mysterious property of the mass, its total energy. The famous equation E equals mc squared was obtained by Einstein when he worked on the special theory of relativity, calculating relativistic kinetic energy using Lorentz transformations. Einstein discovered an unexpected byproduct of these calculations to be an energy term, which does not vanish at zero speed. He called it rest energy. It is the energy which every massive body must possess even when being at rest. To get the total energy of mass, the relativistic mass should be used in equation. Let's consider problem of the total energy of mass from the point of view of new theory of gravity. In a new theory, absorption of space by mass is responsible not only for gravity, but also for the motion of mass in space. Massive object always absorbs space in the same quantities independent on its state of motion. It doesn't matter, is it moving or staying still. Total energy of mass can be defined as a sum of gravitational and kinetic energies. Let's consider three different options for space absorption by the particle of matter. First, when mass absorbs space symmetrically relative to its center. In this case, particle of matter cannot move in surrounding space because any motion in one direction is always compensated by the motion in opposite direction. Of course, bigger mass absorbs more space and therefore has more lines of space absorption. This particle has no kinetic energy, but gravitational flow is maximal. In this case, the total energy of mass is equal to its gravitational energy. Another extreme case when particle absorbs space only from one direction. In this case, no one line of space absorption is compensated by absorption in opposite direction, and therefore, particle moves with the maximum speed, the speed of light. When mass is moving with the speed of light, it doesn't create any space flow towards itself. Total energy of mass is equal to its kinetic energy mc squared divided by 2. Why total energy of mass is not equal to mc squared must be discussed later, probably in a next video when we'll be discussing nuclear bonds. And here we can do an important conclusion that mass absorbs space with the speed of light or even faster. This conclusion gives a physical meaning to the speed of light as an ultimate velocity of any material object. Let's talk a little more about mass as a property of matter to absorb space. I already mentioned that the bigger mass absorbs more space cells in one cycle of space absorption than smaller mass, and therefore has more space absorption lines. We can say that mass can be measured by the number of lines of space absorption, or by the average solid angle attributed to one line. The average solid angle specific to a certain mass can be calculated dividing the total area of the unit sphere 4 pi, by the number of lines. Actually, a solid angle corresponds to the density of absorption lines, and in our case with symmetrical and uniform absorption, the distribution of the lines can be represented by a sphere. Uniform distribution of the lines of absorption means equal acceleration of a space flow towards the particle of matter from all directions, which is equivalent to uniform gravitational field around the particle. Uniform gravitation in its turn indicates that the particle is stationary. Now let's consider an asymmetrical absorption of space by a particle of matter. This is the most common case, when particle of matter is moving with velocity lower than the speed of light. As we can see, particle absorbs space asymmetrically, and therefore moves in the surrounding space in the direction where it absorbs more space. We can define a condition of the motion in space through the solid angles. Average solid angle must be bigger than the angles in front of the particle and smaller than angles at the back. Frontal solid angle of the particle of matter can be considered the same way as a de Broglie wavelength, which is inversely related to the momentum of particle. Smaller angles correspond to a bigger mass and higher velocity. Quite possible that when we measure a wavelength of a moving particle, using diffraction or interference patterns, we are actually measuring solid angles of its space absorption lines. At the same time, every asymmetric distribution of the lines of space absorption can be presented as a superposition of the symmetric and asymmetric parts, which correspondently represent gravitational and kinetic components of the energy of mass. As we can see on this picture, symmetric part of the moving mass which is responsible for its gravitational properties is not uniform, as opposite to the uniform gravitational field in a case of stationary masses. It can be represented by an ellipsoid which axis of symmetry coincides with the direction of motion. Such distribution of the density of the absorption lines indicates that gravity of the moving mass is stronger in the direction perpendicular to its motion. It's important to notice that the shape of the gravitational field of the moving mass is not changing when the direction of motion is changed to the opposite one. I have to mention that every new theory has to predict something new, explain something that previous theories couldn't explain, or at least provide new, more obvious, and convincing explanation of the well-known phenomenon. Otherwise, why do we need new theories? Tidal forces are explained by contemporary physics using difference in strength in gravitational field of the other body. For example, Moon attracts closest side of the Earth slightly stronger than its farthest side. I don't want to argue with this explanation, but new theory provides different approach to this problem. It is based on the conclusion that gravity field is stronger in a direction perpendicular to the motion. It means that the highest tides should happen when the Moon is on the same line with the Earth and Sun. Along this line things are getting heavier, not lighter as it's supposed to be by the regular theory but heavier. The bulges on the opposite sides of the ocean are created by the same reason as more iron fillings are gathering around poles of the magnet, where magnetic field is stronger. And this explanation of tides can be easily checked experimentally, which is important for verification of new theory of gravity. Part 3. Newton's law of universal gravitation. Theory of gravity cannot be accepted if it doesn't allow obtaining the Newton's law of universal gravitation. In a first part of this presentation we agreed that gravity is not a force and therefore Newton's formula for the force of gravity should be transformed into formula for gravitational acceleration of the flow of space. And this formula for gravitational acceleration could be easily derived from proposed premises but with one condition. And condition is, it is possible to obtain the Newton's inverse square law, only if the volume of the space cells will be inversely related to the square root of the mass density, otherwise it won't be inverse square law. This intermediate formula is very important by itself, because it shows that the size of a space cell is decreasing on the way to the mass and that its value defined only by the local density of mass and nothing else. On a picture we can see a sphere around a mass. It's the gravitational sphere of influence where internal mass controls the size and, as we will see later, the speed of the space cells on their way to the massive object. The boundaries of this sphere are defined by the equality of the densities of internal and external masses. The outer field, that I call background space, is under the influence of external mass which is much bigger than the mass of internal sphere and produces much bigger sphere of influence. Good example is a solar system where Sun produces huge gravitational sphere of influence which covers all spheres of the planets, but planets on their turn cover all their satellites. Gravitational sphere of influence is equivalent to the Hill sphere in astronomy. But let's return to the Newton's law. Derivation of the equation for acceleration of the space flow toward the mass is based on assumption that space absorbed by particle of matter should be replaced by the flow of space from outside. We know that the mass can absorb a certain amount of space cells at once. The volume of absorbed space could be calculated by the formula 1. Or by the formula 2, where we use the notion of elementary mass which absorbs only 2 space cells in a cycle and can be used as unit of mass to measure all other masses. Elementary mass may be a pure theoretical particle or may be just a lightest known particle like neutrino. By the way, the final products of annihilation of any pair of particle and antiparticle are photons and neutrinos. We also know that the volume of space cells inversely related to the square root of the density of mass. Using these formulas we can obtain a formula for the volume of space absorbed by particle in a time of 1 cycle. This volume of space is compensated from outside by the flow of space with the velocity v at a distance r. From the last equation we can get a formula for a velocity of space flow at a distance r. And after some transformation we can get a formula for acceleration. Or in the other form using gravitational constant. From the value of gravitational constant we can make an assessment of the order of L0. We have to remember that L0 is the smallest possible size of a space cell on a surface of the particle. It is interesting that the formula for velocity of the space flow exactly coincides with the formula of escape velocity, which means that the space moving through the surface of the Earth with the velocity 11.2 km per second, which looks too high at a first glance. This high speed of a space flow cannot stay undetected. But let's look to the experimentally proven formula for gravitational time dilation. Here is the formula for gravitational time dilation if we write it in terms of time intervals. It can be compared with the time dilation due relative velocity. We can see that if in a second equation instead of v, we'll use formula for escape velocity, we can get exact equation for gravitational time dilation. So the high velocity of the space flow is confirmed by the equation of gravitational time dilation which was verified experimentally. Besides of the Newton's formula for gravitational acceleration, it is possible to get very useful formula which connects linear size of a space cell and its velocity under the influence of the mass m. From the formula for the volume of space cell and a formula for the velocity of the space flow, it is possible to get this equation. Or in the other form, it shows that the product of the linear size of the space cell to its velocity is a constant for a certain mass. The smaller space cells move faster than bigger ones, or decelerating cells are getting bigger and accelerating cells are getting smaller. Alternative theory of gravity. Part 4. Time. Here is the one of many definitions of time. We have the illusion, at any given moment, that the past already happened and the future doesn't yet exist, and that things are changing. Everything in this definition is true. But now let's talk about basic properties of time which can be deduced from the new approach to interpretation of gravity. In a theory of gravity where mass is absorbing space, and motion in space is intrinsic property of matter, time is shrinking to a point that we call now, and which means that there is no other time but now. If there is no time except now, then now is absolute and the same for entire universe. It means that time doesn't exist as a dimension and cannot be warped or bended as it was proposed by Einstein. At the same time, mass is absorbing space in cycles. It absorbs certain amount of space cells at once, then another set of cells, and so on. These cycles can be considered as a ticking clock inside a particle. Duration of one tick is a unit of time which can be calculated using linear size of the space cells and speed of space absorption. Linear size of space cells in this formula is a variable value and is a function of the velocity of the particle, its mass, and the background density of external mass. It means that every particle has its own rate of absorption of space cells and therefore has its own time. Shorter time unit means faster time for the particle. Formula for time dilation in a new theory is slightly different from formula that we know from Einstein's theory of special relativity. Besides speed of light c, it also uses speed of space absorption ca, which is always higher than the speed of light. I will not show the derivation of this formula, but I would like to notice that in a new theory of gravity the real constant is the speed of space absorption, and the speed of light is changing depending on the surrounding conditions. For example, the speed of light in a glass is different from the speed of light in air, or in vacuum. Generally speaking, the maximum speed of any particle or electromagnetic wave depends on the size of the surrounding space cells, but the speed of space absorption is always the same. We can get well-known Einstein's formula for time dilation from the equation 1, only if we assume that in certain conditions speed of light is equal ca. There is one more interesting conclusion which is possible to get from the formula for time dilation. If particle moves with the velocity equal to the speed of light, then its time doesn't become infinity, as it was in special theory of relativity. It has a real value which is possible to calculate using following equation. Now we have come to the part where we'll talk about implications of the new theory, about repulsion of masses and critical density of mass. But first let's talk about real and fictitious forces. We agreed that the gravity is a fictitious force, but what does it mean in the terms of new theory? The particle of matter moves in free fall with acceleration just because it is moving together with accelerating space, but not because any external force makes it accelerate. Here we come to a conclusion that real force must make mass accelerate in space. An acceleration in space happens when solid angle in front of the particle is getting smaller in time, or in a case of the repulsion forces the solid angle in back of the particle is getting bigger. In a case of interaction of masses we are talking about force of repulsion because in a certain condition masses start competing for space. Let's consider a situation when two material objects are moving towards each other and their spheres of gravitational influence intersect. At some point both objects will try to pull the same space cells, trying to absorb them. We know that decelerating space cells are growing in size, which makes the massive objects change their direction of motion. And this is an example of the real force, the force of repulsion. The real force between masses is repulsion. Then force between mass and antimass is attraction. And now let's consider a concept of the critical density of mass, which is coming from the new approach to explanation of gravity. Concept can be explained on an example of a sphere of radius r, with mass m, and the uniform density of mass ρ. All the space inside sphere is coming through its surface. The size of incoming space cells is defined by the density of mass. So, the surface of the sphere restricts the amount of space cells, which can move inside of the sphere, and therefore defines the maximal mass of the sphere mc. It is possible to derive an equation for critical density of the mass, when the surface area of the sphere is big enough to intake exact amount of space to feed the evenly distributed mass m. In logarithmic form it looks like this. This model of critical density of mass shows the situation when particles of matter start competing for space within a limited volume of sphere, and it is obvious that the easiest access to the incoming space cells have the particles located closer to the surface, which means that the struggle for space between particles is going to be somewhere closer to the center. And the result of this struggle will be flows of particles directed towards the surface of the sphere. But gravitational flow of space will move more mass toward the center, creating circular flows of masses within the sphere. The process like this can be observed in the depths of the planetary objects. It keeps the center of the Earth hot and can do it eternally. Now we can consider an extreme case of a critical density, when the density of the object is so high that its escape velocity equal to the speed of light, which means that all the mass of the object has moved from inside to the surface. This is a model of black hole. We can describe this model as a sphere which surface is covered by elementary masses, and these masses absorb space only from outside. The formula for critical density in this case is different. This model suggests that the space cells inside of the sphere must be much bigger than cells outside, because no one line of space absorption from mass on the surface, directed into the sphere. The concept of critical density can be applied not only to cosmic objects but to the elementary particles also. The density of mass of atoms' nucleus is extremely high, and competition for space can be expected inside of the nucleus of the heavy atoms. Now we can analyze objects of our solar system from the point of view of the concept of critical density. On this picture you can see all out planets and Sun on the same chart with the heaviest element, unoctium with atomic number 118. Formula for an automatic trend line is different from the formulas derived from the proposed models, but we know that no one object on this chart fits exactly to any of discussed models. But if we'll try to put on this chart object from our regular life, like a 100 kilograms body, then it will be necessary to squeeze this object to the sphere of 2 millimeters in diameter. But now let's consider objects of our solar system more closely. We can see two groups of the objects, the rocky planets with relatively high density of mass and a group of the low density but more massive gas giants and Sun. All of the objects are stable and therefore located on the left side from the line of the critical density, but the distance from the critical line is different for each object. This distance defines their internal activity. In a low-density group of objects we can distinguish Sun and Jupiter, which is often called as a second Sun. And in a group of rocky planets, Venus and Earth are distinct subgroup of very similar planets with known volcanic activity which indicates to the hot and at least partially liquid cores of the planets. Venus has a slightly lower density than Earth and has no magnetic field, which may be a consequence of its extreme volcanic activity which spills internal masses to the surface of the planet, decreasing the density of the planet. Mars is staying apart in the group of 4 terrestrial planets because of its low density, which predefines it to be a cold planet, but the number of huge dead volcanoes on its surface suggests that in a past Mars was much hotter. Using conception of critical density we can assume that in a past Mars could be hotter and denser, but volcanic activity cooled it down by decreasing its density of mass and making Mars look as it looks now, frozen, dead planet, with very thin atmosphere and without any magnetic field. New approach to explanation of the nature of gravity can be also helpful in understanding of some other problems of contemporary physics. For example, the rotational curves of galaxies can be easier explained when it's accepted that the space can move under the influence of mass, and that density of mass defines its velocity. In case of galaxies it won't be necessary to have more mass at the center, or apply a halo of dark matter to make a disk of galaxy rotate faster. Unusual rotational velocities of the spiral arms of the galaxies can be explained as a result of their relatively high mass density. And at the end I would like to remind a well-known saying of Einstein. Once he said about thermodynamics, a law is more impressive the greater the simplicity of its premises, the more different are the kinds of things it relates, and the more extended its range of applicability. In my opinion it's an absolutely correct statement and proposed criteria can be used for any theory not only for thermodynamics. As you could see from above presentation, the range of applicability of proposed theory of gravity is really wide, it can explain many things which were not in a range of competence of general relativity. This is the last slide of my presentation. Thank you for your attention and please write your comments to this video or ask questions. See you in new video. The end.